Hey guys. All right, I'm gonna talk to you a little bit about some of this new material on machines. So I'm gonna flip the phone so I can show some pictures from the book and that sort of thing. First of all, simple machines, we got 6 of them. Okay, so first of all, we have a lever. Okay, so a stapler would be an example of a lever, or something basic like this is a lever. A lever is just something where there's a fulcrum, which is like a pivot point, and then you have a bar on it. Okay, so that's a lever. Stapler is a lever. Here they're using a baseball bat. That's a lever where your wrist is acting as the fulcrum. Here in a stapler, the fulcrum's right here. Okay, so you have levers. You have a wheel and axle. Okay, so here with a faucet, for example, there's your wheel portion, and then this cylinder, that's this post that's attached to it, that's your axle. Okay, or here's another picture of a wheel and axle. So that's number 2. The third type is a pulley system. Okay, there's different types of pulleys, but it's basically a wheel and a rope or a cable, something like that. Okay, so that's 3. And then we have inclined planes, so just like a basic ramp, some sort of slanted surface would be an inclined plane. And then you have a wedge, which is some sort of cutting device that's used to split something. An axe, for example, or a knife. Your teeth are a wedge. And then lastly, we have a basic screw. Okay, so those are the 6 simple machines. Now, that should be review for you, because you would have learned that at some point. But the one thing I want to talk to you about that you probably haven't learned about is called mechanical advantage. And they start talking about mechanical advantage on page 106. So think of it this way. Mechanical advantage is how much a machine is helping you out. Okay, so the higher the mechanical advantage, the more that machine is helping you. All right, so if something has a mechanical advantage of 1, that means, like, take your force and multiply it by 1. Okay, so if you're putting 100 newtons of force into something, 100 times 1 equals 100. That means it's really not helping you by multiplying your force. All right, but if a machine has a mechanical advantage of 2, now it's taking my 100 newtons of force, multiplying it by 2, and turning it into 200 newtons of force. So it's multiplying my force by 2. Something has a mechanical advantage of 10 helps you more than something that has a mechanical advantage of 2. So the higher the mechanical advantage, or you can abbreviate it as MA, the higher the MA, the more the machine is helping you. Okay, so if you look at a basic, like a pair of scissors, for example, all right, you have your fulcrum, that's the pivot point in the middle, okay? And then you have, remember we were talking about fin and fout one of our last days in class, fin, fout, win, wout, all that stuff. So where I'm putting my fingers in the scissors, that's where I'm putting the force into this simple machine. So this is the fin. All right, and then over here, where the force is coming out of the scissors, that's your fout. Okay, so that's a first class lever. Okay, so fulcrum, fin, and fout. Now let me show you a little bit about mechanical advantage of, like, twist this around here. Okay, of trying to hold this, pair of scissors. So draw a pair of scissors here. I'm going old school here, okay? All right, so there's my scissors. We've established, we know, I'm having trouble holding my phone. All right, so this right here, that's the fulcrum, okay? So this is where you put your fingers, so that's your fin, we'll label that. And over here, so this is where the force goes into the machine, right? And then the force is going to come out over by these blades, so that's your fout, all right? So then you can measure the length of this input arm, okay? So your input arm is going to be from the fulcrum to where the force goes in. So this is your input arm. And over here is going to be the length of your output arm. Now, a lot of this information's in your online textbook, so I'm just kind of wanting to explain mechanical advantage to you a little bit, but go through that online textbook and it'll help clarify a lot of the questions that you may be having. All right, so we know where things are, right? Now, if we look in our book here, okay, so to find mechanical advantage of a lever, this is on 108, you take the distance of the input arm over the distance of the output arm, okay? So to find MA of a lever, you take distance of input, divide it by the distance of the output. All right, so let's say that this pair of scissors, we measure it and the input arm is 6 centimeters long. And then let's say we measure the output arm over here and it's 2 centimeters long. Well, all you got to do is take the length of your input arm, 6, and divide it by the length of your output arm, which we said is 2. That means those scissors have an MA, there's no unit on it, it's just the number itself, an MA of 3. So they're helping you 3 times, okay? So let's compare those scissors to, I'll draw another pair here, okay? And I'm gonna make these ones look a little bit different. Okay, so you see how this input arm is larger than this one. All right, so let's say that this input arm is 12 centimeters and this input arm here is still 2 centimeters. See the difference? Now you're gonna take input arm 12 over the output arm of 2. Now you have a mechanical advantage of 6. So these scissors here help you more. You have to go a longer distance when you're using them, but you're going to gain more force out of them. They have a higher mechanical advantage than these scissors here, all right, where the input arm isn't as long. And you can figure out mechanical advantage with all your simple machines, and in the book that explains that a little bit. So for example, if you look at the wheel and axle page on 110, all right, so you just take the radius of your wheel and you divide it by the radius of your axle to find the mechanical advantage of that. All right, and it has, I'm pretty sure one of the questions I'm having you do is to do that. So in this case, the radius of your wheel is 5 centimeters. The radius of the axle is 1 centimeter. 5 divided by 1, that has a mechanical advantage of 5. If this wheel is larger, right, you have to go a greater distance, but you gain force. It's going to have the bigger the wheel, the higher the mechanical advantage. That's why a ship, for example, has an enormous wheel, whereas a car has a small wheel, because you need more force to, steer a ship than you do for a car. So you have to go a greater distance, but you gain a lot of force out of it. All right, and then there's all the other formulas in here for how to find the mechanical advantage of the inclined plane and so on. Okay, all right, so that gives you a better idea of mechanical advantage. Go through the online textbooks and it'll kind of clarify things as well. All right, see ya, bye.